Okay guys, we're going to talk today about nuclear and chemical reactions. Chemical reactions always form new substances based on the elements that are present in the reactants. They incur small energy changes, and these energy changes come from breaking and forming new chemical bonds, and they involve valence shell electrons. Nuclear reactions form a new isotope or a different element. They have extremely large energy changes, and those come from the binding energy of the nucleus, because that's what we're messing with, is the nucleus. It involves a change in the number of protons and neutrons. Okay, there are 4 steps in writing nuclear reactions. Step 1 is you set up 2 equations, like these down here, one using the mass, or the top numbers, and the other using the atomic, or the bottom numbers. Step 2, you calculate the missing mass numbers. So here we have a mass number of 29 for magnesium, and we have 0 for the beta negative particle. So what plus 0 is equal to 29? Well, that should be the number 29. After that, we calculate the missing atomic number. So the atomic number for magnesium is 12. The atomic number for this electron is a -1. So we have to ask ourselves, what number -1 equals 12? And you should say 13. So then we are going to look, for step 4, we're going to use the atomic numbers and the mass numbers to determine the identity of the missing particle. So we need to find something, or what atom has the atomic number of 13. And that is aluminum right here. Aluminum has the atomic number of 13, so we have just produced an aluminum isotope. And I'm going to put 13 down here at the bottom because that's our atomic number, and our mass number is 29. Now if you notice, all of these numbers, your arrow should be equivalent to an equal sign. 29 equals 0 plus 29, and that is good. 12 should equal a -1 plus 13, and that is good as well. Okay, now we're going to talk about a few emissions. Helium nucleus. Alpha emission is the emission of a helium nucleus, which contains 2 protons and 2 neutrons. An example of alpha decay is americium-241, turns into neptunium-237, and it gives off an alpha particle. Now if you notice, 241 should equal 237 plus 4, and it does. So our top numbers, our mass numbers, are equal, or they're balanced on each side of the equation. Now our atomic numbers must also be balanced. 95 is equal to 93 plus 2, and it is. Examples 1 and 2 we're going to go over in class for alpha emission. Beta emission is when a neutron is converted into a proton and an electron, and then the electron is emitted. So we call that beta emission. So let's look at the beta decay of carbon-14. So carbon-14 over here has a mass number of 14 and an atomic number of 6. And if it emits an electron, we know the charge on or the mass number on an electron is 0, and the atomic number on the electron is a -1. So all of these numbers have to be balanced, which is on the product side, the numbers have to add up, the mass numbers have to equal the numbers on the reactant side. And the same thing for our atomic numbers. We have to do this for nuclear equations. And 6 is equal to 7 minus 1. So we're good. We're going to go over numbers 3 and 4 in class as well. So positron emission. Now remember, a positron is a positively charged electron, and this happens when a proton is converted into a neutron and a positron, and the positron is emitted from the nucleus. An example of this would be carbon-11, and it will turn into boron-11 and emit a positron. So the mass numbers have to be balanced on each side of the equation, so all of the reactants' mass numbers have to add up and equal all of the products' mass numbers. And the atomic numbers of all of the reactants have to add up and equal to all of the atomic numbers for reactants. Now we will go over 5 and 6 for positron emission in class tomorrow. Electron capture. This is when the nucleus captures an electron and it combines with a proton to form a neutron. So if it's capturing an electron, it will be on the reactant side. And so the mass numbers, you add them up and they have to equal or be balanced on the reactant side and the product side. So beryllium-7 will combine with an electron or capture an electron, and one of those protons of berylliums will turn into a neutron. So beryllium-4 minus 1 has to equal 3, which makes a lithium atom or isotope. We'll go over number 7 and 8 in class. Now, gamma emission. Gamma rays are emitted during nuclear reactions, either alone or with other types of radiation, and they do not change the mass number or the atomic number because they are energy and they are not matter. So over here, polonium-240 emits a gamma ray, so it is an excited element or isotope. It emits a gamma ray, and it still remains polonium-240. It's just at a lower energy state. Thanks for watching, guys.